Hi, my name is Dear Tiagi, and in this video, I'll be going over everything you need to know to solve geometry problems on the SAT math section. So to start, I'll go over some formulas and we'll go over some problems to see how to solve them. So to start, if we have a parallel line and a parallel line, and these two parallel lines are being cut by a transversal, then the angles in this system have a special relationships. So first, we have the relationship that alternate opposite angles are equal. So 1 and 2 are equal, 3 and 4 are equal. And again, this is true because the two lines are parallel. So 1 and 2 are equal, 3 and 4 are equal, here and here are equal, and here are equal. Next, we also have that opposite angles, like so. So 2 and 3 would add up to 180 degrees. Similarly, 1 and 4 add up to 180 degrees. And again, the reason why this is true is because let's imagine 3. So when we have a line, right, and it's being cut, then the sum in the angle of the line is 180 degrees. So 3 has an equal part here, call this x, right? And because this line is parallel, this equal part is also equal here, and it's equal to x there. Therefore, alternate interiors add up to 180. Next, if we have a shape, any shape, with n sides, okay, so n sides, the sum of the interior angles, so these angles, is equal to n minus 2 times 180. So for common shapes like a triangle, n is equal to 3 because there's 3 sides, so 180 degrees is the sum of all the interior angles. For a four-sided shape, 360 because 2 times 180 is 360, and so on. Next, for a circle, let's imagine we had a circle, okay? Call this the center. The degrees in a circle are equal to 360 degrees, or in radians, 2 pi. So 2 pi is equal to 360 degrees. And we can use this conversion whenever we want to convert from radians to degrees. Let's say we have x degrees, and we want to convert it into radians. Using this fact, we can say, using unit conversions, that 2 pi over 360 degrees, and that'll give us our answer in radians. And the reason why this works is because 2 pi equals 360 degrees. So really, we're multiplying by nothing. All we're doing is just changing the units by using this unit conversion. All right, next we'll work on triangles. So let's say we have a triangle ABC and DEF, and these two triangles have two angles that are similar to each other, or the same. So because these two angles are similar and these two angles are similar, these ABC is similar to triangle DEF. So the triangles are similar. And when the triangles are similar, what we can say is that their side lengths are proportional. So the way we write this mathematically, we can say that AB over, let's say, AB over BC, the ratio there is equal to the ratio ED over EF. And again, the reason why this works is because the two triangles are similar, which we can prove using AA similarity or other similarity theorems. And because they're similar, the side lengths are proportional by this equation, or by other equations we can make because the side lengths are proportional. And for congruency, we can test congruency if two triangles are equal by a multitude of theorems, some of them being SAS, SSS, AAS, etc. And again, side angle side, side side side, etc. It's this test for triangle congruence. Next, let's say that we have a triangle, right triangle, right? And the angles are 30 degrees, 60 degrees. So the important thing about know about this, memorized, is that the length here is x, the length here is x root 3, and the length here is 2x. Because it's a 30, 60, 90 triangle. And if you use the Pythagorean theorem, you'll see that this holds. Similarly, for a 45, 45, 90 triangle, the angles are the side lengths are x, x, and then x square root 3, or square root 2. Next, Pythagorean theorem. So if we have a right triangle, side lengths a, b, and c, we can relate them all by saying that a squared plus b squared equals c squared, if this is a right angle. Finally, let's go with some trig. So for trig, the important thing to memorize is SOHCAHTOA, which basically tells us that for a right triangle, let's label this, let's say for this angle x, right? If we take the sine of x, what we do is opposite over hypotenuse, so opposite over hypotenuse, which is the side length opposite to the right angle, so the largest side length. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so if you know that, then you can solve any trig problem in the SAT. And finally, let's end off with some circle stuff. So for a circle, let's say we have a circle here with lengths like that. This is the center, this is a radius. And let's say we want to find the length L here, given that we know the angle here, let's call it x. So we know the total circumference of a circle is equal to 2 pi r. So this length L is going to equal to the circumference times the fraction it makes up of the circle. And this fraction is equal to x divided by 360, or 2 pi. So our formula, 2 pi r times xr over 2 pi is equal to x over r if we're using radians. Similarly, the area is equal to pi r squared. And again, we want to find a fraction of that area, so times the fractional part. This fractional part is again equal to x over 2 pi. So pi r squared times x over 2 pi. And we get r squared divided by 2 times x for the area of a sector, which is what that's called. Next, for angles in a circle, what you guys need to know is if we have a circle like so, and we have that's the center, and we have an angle created like so, then an angle like here. So this is called a central angle because it's an angle created using the center of the circle, and this is called an inscribed angle. Let's call this one x, let's call this one y. So the relationship between x and y is that here x is equal to 2x here. So the central angle is double the length of the inscribed angle, and the reason why they're related this way is because they both circumscribe the same arc. And finally, the formula for a circle is x minus h squared plus y minus k squared equals r squared for in the coordinate plane. And hk is the center coordinate of the circle, and r is the radius. So when we're graphing it in the coordinate plane, what we get is we get a circle like so, center is hk, and the radius is r. And there's also the distance formula, but the distance formula is just a rehash of the Pythagorean theorem. So if you ever need to use that, just think about the Pythagorean theorem and you'll be able to figure out the distance between 2 points. Okay, so let's now try out some problems. So let's start off with a circle problem. So let's say we have a circle here, and we have a chord AB, like so, and we have a center of the circle O here, and the radius of the circle is 18. Okay, call this C, call this O. So because these two are radiuses, this means this is equal and this is equal. And also, sorry, I forgot to say, this is also equal to 30 degrees here. Okay, and let's say we're trying to find the arc length AB. Okay, so we want to find the arc length of AB. So the idea here is we need to find this angle here, because we find that angle, we know what the radius is, so the total area is equal to 18 squared times pi. So we know the total area, we just need to find the fractional area to find the arc length. Sorry, not the total area. We want to find the arc length of AB. So we know that the total circumference, is equal to 36 pi. Okay, so we want to find out what portion this arc makes of the total circle, which we can do if we know the angle here. And so because these two radiuses are equal, because they're both radiuses, we know this is an isosceles triangle, and from that, the sides opposite to the equal angles are equal, so this is 30 degrees as well. And we know that the sum of the area of the interior angles in a triangle is 180, so this has to be 120. Therefore, our arc length, AB, is equal to circumference, 36 pi, times the fractional area that this arc length makes. It makes 120 out of 360 degrees, so 1/3, which equals 12 pi, which is our answer for the arc length AB. Okay, next. Let's say we have a right triangle, x, y, z, and let's say that they give us that tangent of x is equal to 12 over 35, and that this length, yz, is equal to 24. And we want to find the perimeter of xyz. Okay, so tangent of x, what does that mean? Well, SOHCAHTOA, right? So the angle here, x, is equal to TOA, opposite over adjacent, so opposite over adjacent. So this ratio, 12 over 35, is equal to the ratio 24 divided by the xz, because again, opposite over adjacent is what tangent means. Okay, so if we solve our xz, then we see, okay, we're multiplying this by 2, multiplying this by 2, therefore xz has to be equal to 70, so we have 70 here. Now that we have 70 here and 24 here, it's a simple matter of just using the Pythagorean theorem to find the length of the hypotenuse. So a squared plus b squared, so 70 squared plus 24 squared equals c squared. And so if we plug this into Desmos and use, the calculator to crunch this out, what we get is c equals to 74, and so this is 74, and therefore our perimeter is 74 plus 70 plus 24, which is 168. So again, the process here, we used the information of tangent, which again gave us a ratio of the side lengths, opposite over adjacent. We used this ratio to find this length, and then we used the Pythagorean theorem to find the other length, and we summed those to find the perimeter. Okay, lastly, let's do one more. Let's say we're given this diagram, right? And we're told that the angle here is 45 degrees, and we're told that the angle here is 104 degrees, and we want to find this angle here, x, okay? And one more thing, we know that this angle, this length, side length here, this side length here are equal, so let's call this A, let's call this B, let's call this C, so AB is equal to AC. So we know those pieces of information. Okay, so we want to find this angle here. Well, we know that these side lengths are equal, and so the first thing we can say is that this side length here and this side length here are equal. So let's call this one x, right? This is also x. Actually, don't call it x because we already have an x. Let's call this y. This is also y. And so we can see there's a triangle here being made. We know the sum of the angles in the triangle is 180. So y plus 104 has to equal 180. And so now if we solve for y, what we get is y is equal to 38 degrees. So this y here is 38 degrees. Okay, great. So if we now know, or if we want to find x, we can now need to find this angle here, because if we need that angle, then we could use, again, the idea that the angles in a triangle add up to 180. So we need to find this one. Okay, well, if we know this is 104, we know that this side has to be equal to 76 degrees. Because again, for a line, if you have a line that's cutting a line like that, you know that they're supplementary, which means they add up to 180. So 180 plus 104, or sorry, 180 minus 104 is 76. And now we just do the same thing with the triangle. So 76 plus 45 plus, call this maybe z, equals 180. Solving for that, we get that z is equal to, 39 degrees. And so if this is 39 degrees, right, then this has to also be 39 degrees by the fact that they both are vertical angles, orthogonal angles. So this is equal to this, 39 degrees. And now using this fact, we can find out that x has to be equal to 83 degrees. And again, we just use the idea that the sum of the angles in a triangle equals to 180 degrees. So while this was a complicated problem, the process was really simple and boiled down to just one formula, the sum for the angles in a triangle. And yeah, that's some problems, and that is everything you need to know for the SAT geometry section. Thank you guys all for watching, and I'll see you guys all tomorrow. Bye.